welcome our next speaker for this session, Werner Vogels, CTO of Amazon. Let's give him a big, warm Malaysian round of applause. Over to you, Werner.
Okay, thank you all for having me. Can you guys sit down, please? Yeah? I know everything else is more important than what I have to say, but it would be nice if everybody else could hear me. So first of all, thank you all for having me here. You'll hear during my talk maybe a little bit of controversy with what some of the investors just have told you. Yeah, so I may have a different idea about where we are with AI and how it will impact the world. Why are we here? Is because AWS, the cloud computing division of Amazon, has been supporting startups from the early days. Actually, it was one of the drivers for building our infrastructure. Through our Activate program, we've supported 280,000 startups worldwide by now. And I fondly remember coming, first time meeting startups here in Malaysia in 2015. And we've really put things on the ground here, a team on the ground that really supports startups in Malaysia and also in the rest of Southeast Asia. We also will launch a region here in Malaysia, hopefully still this year. And that will actually help both local companies to be able to meet regulatory requirements and things like that, or deliver better sort of latency towards your customers. One of the things that I've become really interested in is whether all this technology that we are building, there are a number of really major challenges in this world. And whether we can actually use this technology for good. And specifically, of course, you know, now that AI is the buzzword all around the world, whether we can use AI for good. Yeah? Not just to be the next billion-dollar startup, but to really have impact on the world by solving really hard human problems. And that's really crucial, I think. The quote that you have to remember throughout this presentation is from John McCarthy, who is one of the founders of the AI movement all the way back to the 60s. And McCarthy made this statement that as soon as it works, we don't call it AI anymore. I'm not really sure whether the inverse works as well. Like, if we call it AI, it probably doesn't work. Yeah? But at this moment, you have to realize that AI is not something new. Yeah? Large language models, where most people are talking about, and generative AI is something that has been a year and a half in the market, but there is a whole massive body of work that goes back a very long time. Actually, it goes back all the way to the time of Plato and Aristotle. They were the first ones to discuss whether we could add logic and machinery thinking to machines. Yeah? Actually, all the way that if you look at Plato's The Republic, his famous book in which he describes an ideal city-state, he would have robots doing household work. This is 3,000 years ago, and people were already thinking about how we can actually make use of human capabilities, but transform them into what we now call programs, but in those days, into machinery. And so all of that, you know, because one of the things that was really important with the earlier thinkers is that they thought the brain was a logic machine. And to be able to have all these machines do human tasks, they also needed to have a logic machine in their head. And it wasn't until actually we brought computers to life in the 40s, 50s, in that particular time frame, that we actually got machines that could execute logic. And as such, they were ideal to think about, can machines think? Yeah, after all, you probably all know about the Turing test. Alan Turing was one of the first ones that posed the question, you know, can machines think? And the famous Turing test is there, can we as humans distinguish machines from humans in terms of answers? But again, unfortunately, Turing didn't make it to this particular workshop in Dartmouth in 1956, where for the first time the word artificial intelligence is being introduced. And again, you see famous names as John McCarthy and Minsky being part of that particular group. They still thought the same way as Plato and Aristotle were thinking, namely that the brain was a logic machine, and that if they want to build artificial intelligence, it needs to be like a logic machine. Well, it turns out they went nowhere, or at least not in those days. These days, we have automated reasoning and things like that that play a very important role in, for example, security and resilience and things like that, but they weren't there in those days. Actually, the first sort of systems that came out of that thinking were called expert systems, basically rule-based systems. Yeah, that's me. I actually, in those days, I'm a bit older than all of you. I had hair. That's one thing there. But also, I was programming in Prolog to build these expert systems. They are nowhere as successful as that where we are now. What really made the biggest change in AI, and I'm giving you this little bit of history such that you have the context of it, is the moment that the researchers left the idea that they should emulate a logic machine like the brain. First of all, I don't really think the brain is a logic machine, but that's a whole different conversation. Embodied AI was, can we emulate a number of the senses that the humans have and actually build computer systems that exactly emulate those senses? Yeah? Speech to text, listening, speaking, vision, object detection, sensing, all these kind of things. And they basically came out of the robotics world, or drove the robotics world, because they needed these kind of technologies. And so this embodied AI was actually the first attempt of AI that really worked. And, you know, for example, now, this is one of the warehouses of Amazon. We have basically 30,000 robots running around in these warehouses, performing all sorts of different tasks. Yeah? All of these things don't need Gen AI or anything like that. They need the fundamental AI that just works. And we have a whole body of work that really is like that. Now, each of those steps, every time in sort of progression, was driven by different types of new algorithms that were being built. Deep learning, reinforcement learning, unsupervised learning, and recently, of course, transformers. And transformers allow you to make relationships between text, between words, and then use that to generate new text. Yeah, about the context. Now, that has led to the large language models, which are now driving the whole generative AI movement. But that's not really where I want to talk about. Yeah? I think the whole Gen AI, the new AI movement, is really something where we are only taking the first 2 or 3 steps in what's going to be a marathon. Yeah? This is not going to be a winner-take-all market. There's going to be a large number of companies that are going to be extremely successful, as well as a number of younger businesses that actually are going to use these techniques to actually solve really hard problems. And if you really look at this, we're really at a pivotal moment in using these technologies. And I'm not going to talk about these large language models, about how the future is going to look like. We don't know yet. Yeah? There's a tremendous impact that this technology can have, just as other technologies has had in the past. I really would like to talk to you about the AI that really works right now. Yeah? I call that AI for now. And I'm finally using a number of examples here of companies that actually have attacked a particular set of problems. I know everybody's thinking about startups. You think about they need to be unicorns, they need to become as big as possible in the world, and we need to make a lot of money for our investors. What I've actually learned over the past 20 years as Amazon CTO, and especially here in Southeast Asia, is that there is actually a significant number of startups that are not immediately looking to become a unicorn, but to solve really hard problems that are unique for the region here. That are not looking to immediately move their sales force into the US. They're looking to solve hard problems because they know about these problems, because often they've experienced them themselves. So I'm really going to talk to you about what I would call AI for hard human problems. One of the biggest challenges, of course, that we will have as a society is that, you know, the expectation is that by 2050, there will be another 2 billion people on this planet. What are we going to do with that? Now, if you look at the UN sustainability goals around this, you know, how are you going to make sure that we can feed them? How can you make sure they have healthcare? How can we make sure they have an economic future? And I'm going to pick up on a few of these to actually sort of showcase a number of companies that are using AI to actually really solve hard human problems. If you're interested in listening more to that, I actually made a TV series. You can watch it on Amazon Prime or YouTube or on one of the AWS sites or on my blog. Because I've become really interested in these kind of companies that are willing to actually solve hard problems. They're not writing the next spam filter. They're solving things that are crucial for our society to work on. The TV series is called Now Go Build. There's a QR code if you're interested in watching that. And we've been going all around the world, actually working with the startups that we're working with and promoting them about the good work that they do. A good example there is actually the first episode in this series, is a company called Hara, and they are in Jakarta. So one of the biggest challenges in Indonesia is, and there probably is in quite a few of the other countries in Southeast Asia, is that smallholder farmers do not have an identity. If you do not have an identity, you cannot get a loan at the bank. You need a loan to buy seeds for your next crop. They have to go to loan sharks who charge 40 to 50% of interest. Basically, half of your crop has already been sold, or you're not going to make any money off because it goes directly to the loan shark. So these company, Hara, what they do is actually give smallholder farmers an identity, but they also measure the plot of land, and they measure the yield of that plot of land. And that particular data is crucial for banks and government organizations and NGOs to actually start targeting these. So they also have this, measure this plot of land, go around, and then all that data comes together in sort of a big database that they have, where banks, for example, are eager to get access to. Why? It's because these microloans that are given to these farmers have a 100% repay rate. At a fraction of the interest that the loan sharks charge. So why were these organizations actually thinking about that? Why were the founders thinking about that? Because they were children of smallholder farmers themselves. So they understand what the real problems are that people are actually thinking about. Smallholder farmers don't really care that terribly much about the next version of Gen AI or ChatGPT or whatever. They care about food on the table. They care about an economic future for their children. And that's where these kind of startups are working at. Let's pick up on one of these. This is called AI for Food, what I call AI for Food. Mostly because I think that's one of the biggest challenges that we're going to see if we want to grow the population by another 2 billion. What's the most important food source, especially here around here, but actually across the world, is rice. So how can we make sure that those countries or those communities that depend on rice as their major food source have food security for the rest of their life? How can we improve on sort of growing rice to make sure that the yield is much higher or that the quality of rice changes? There's an important research institute outside of Manila, about 3-4 hours drive out of that. It's the International Rice Research Institute. And they really have as a charge to make sure that to abolish poverty and hunger among the populations that depend on rice. And so they are amazing. They have 200,000 strands of DNA of different types of rice in their freezer. They do continuous research on improving the world for farmers and for those who depend on rice as a food source. Now, they have a challenge, and they have a whole range of challenges where they're using AI for, but let me give you this one because it's such a simple efficiency challenge that works really well in AI that works. So one of their challenges is that they keep getting all these new seeds of rice that they will need to store in their freezer, but they can only store those seeds in there that actually are of high quality. And they had a massive human backlog. But the longer the rice stays in the backlog, it doesn't disappear into the big freezer that they have. It really sort of deteriorates over time. So they cannot have enough people to actually get this in there. So what do these humans normally do? They use vision. They look at them and actually pick out the bad seeds to move away. So they make use of vision AI to actually really pre-sort all these seeds and completely remove the backlog that they have. Now, this is a really simple system and a really simple example, but again, this doesn't generate text or imagery for you. It just works really well as a human sensing vision sensor and object detection mechanism. The same goes for speech and text-to-speech and speech-to-text. For example, one of the challenges that they had is that most of the smallholder farmers have not gotten any education on how to use fertilizer. It's sort of by their grandfather taught them something and others, and they often use way too much fertilizer to be able to get this. So they developed a system for smallholder farmers to actually get advice on that. But you have to remember that most of these farmers, they can't read and write. They don't have cell phones. They don't know what an app is on a phone. They couldn't care less. What they can do is use their voice. They can speak. So Erie developed a system where farmers can call into, describes their patch of land in natural language in the way that they normally speak, and then get advice back how much fertilizer to buy, and when to apply it. Which is extremely important because the runoff of fertilizer often of these rice fields end up into rivers and create massive pollutions in those rivers. And so again, what is the AI part here? Text-to-speech, speech-to-text, and on this being able to do natural language understanding. Again, all AI. Here there's a very interesting company here actually in Kuala Lumpur called Aerodyne. Aerodyne was originally founded in 2014 when they were using drones during a massive natural disaster to get goods to places where they needed to be. Now Aerodyne has a whole range of different applications. They make use of third-party drones and built a whole system around it, for example, how to apply it to agriculture. Or, for example, how to measure carbon sequestration, or how to preserve wildlife. And all of these are actually examples of their technology. Now you have to remember, a drone isn't piloted, often isn't piloted. It needs to do things by itself. It needs to be completely autonomous, which means it has a whole range of sensors that it needs to evaluate continuously while it is in flight. And we'll see more examples of that. Now, if you think more about food, protein next to rice is a very important part of our diet. However, most of the protein that we consume these days comes from cattle, which is a very, very inefficient way of growing protein. Because to grow 1 kilo of cattle, you have to actually have 7 kilos of feed to get actually to 1 kilo of protein. Fish, however, 1 kilo of fish food results in 1 kilo of fish. So it's a way more efficient way in actually growing protein for those who depend on protein in their diet. So, it's really an example of fish farming, which really drives the sort of improvement in creating protein. Now, there's a company called Aquabite, and actually what they have is massive pens in Norway and in Chile and in Scotland, where in each of those pens is about 200,000 salmons in each of those pens. Now, if you put that many salmon together, you run into a whole range of different problems, mostly around disease. So lice, for example, is a problem. If one of these fish develop lice, you are always at risk that all the 1,000 ones gets it as well. So, there's also environment pollution and things like that. So Aquabite makes use of computer vision and sort of to determine which fish are healthy, how they're growing, and whether they're actually meeting the goals of actually growing sufficient amount of protein. So they do this, they have sensors in the water, they have cameras in the water, and again, they make use of AI to follow the growth of these fish. Yeah? And so they can try to determine whether actually these fish have lice and as such need to be removed from the pen. They can't do that as a human. You can't throw a bunch of people in the water with cameras and sit there. This all needs to be automated. And vision, and object detection, and so that the mechanisms for actually counting this is, again, artificial intelligence. Yeah, and they use a whole range of sensors, not just cameras. They also use TUT sensors, you know, saline, temperature, oxygen, all these kind of things, and actually bring that together in a big data analytics part. And they have analyzed well over $1 billion fish, 1 billion fish, which means they have a massive data set to understand the growth of salmon. And while we're talking about sort of water, there's another interesting young startup called Ocean. They built a completely autonomous water vehicle that is capable of inspecting the bottoms of the ocean, and especially of seas, and especially those parts where you would like to build wind farms. They already, I think, saved something like 150,000 tons of CO2 by going from, you know, using traditional ships, which would be used for this, to a completely autonomous green vehicle that can just go, that can sort of survey the bottom of the oceans under any conditions. Now, thinking about sort of, that was food. What's another area that I think if you add 2 billion people, which is going to be really hard? It's healthcare. Yeah? How can we make sure that, for example, I think this number is a pretty low number. 2 billion people, 2 billion rural people are without access to healthcare. I believe that number is much larger than that. But what can we do? How can we actually make use of technology to help people get better healthcare, or even access to healthcare? Now, I think if you're somewhere really out in nowhere, let's say somewhere in Middle Africa or something like that, you're far away from any big city, how do you get vaccines there? How can you make sure that you can actually do things like do analytics on blood data? Things like that. So Swoop Aero is one of these young startups that makes use of these drones to be able to transport vaccines to remote locations and then bring sort of other sort of resources back for analytics. And so you can imagine these drones need to fly for a very long distance. There is no pilot. These drones need to do that by themselves, using vision, using LiDAR, using all sorts of interpretation of what we call embodied AI. Again, a really good example of AI. There were also, by the way, I think this is in, I don't know, 2018, I think. This is the first baby sort of has gotten a vaccine by one of these drones. And so they go out to areas where normally vaccines would never be able to be delivered to, even just not for COVID or things like that, but really for common childhood diseases, which are a major issue. In Brazil, a very large number of people are medically homeless, basically. I mean, the government of Brazil has a national healthcare system, but it really is creaking under scale. And so literally about 150 million of the 200 million Brazilians do not have access to healthcare. And so there's this young business called Dr. Consulta that makes use of data analytics to find the cheapest place to get medicine, or the most effective way for people to actually go through a particular sequence of steps in terms of their medical investigation. Really being able to drive costs down by well over 80%. And so this makes suddenly healthcare available to many of the medically homeless in Brazil. And they've got all their clinics throughout the favelas in Sao Paulo and Rio and in many other cities in Brazil. Another example in healthcare is a young business called Surgenics. So it turns out that 1 in every 200 babies are born with some form of brain injury. But we do not do a test when babies are being born for that. We test for vision and we test for hearing, but we don't test for these major brain injuries that babies can be born with. So Surgenics has developed this system, a really simple system, to do an EKG or an EEG of a baby's brain. It's a very small cap that's being placed on the baby's brain. And basically, within minutes, you can determine whether this baby actually has a brain injury. Often, these brain injuries are small and do not come back to life until years later, when it's too late to treat them. And so these are very simple mechanisms where you see a whole range of different technologies being used to actually solve really hard problems. Yeah, computer vision plays a role in many of those because it makes it look good in a presentation, actually, but there's all these other areas that we have technology in that are very effective for companies to use at this moment. These AI technologies work. Yeah, that's why we often don't call them AI anymore, as John McCarthy says, but these are technology that works, and every company can make use of that right now. Especially, I think it's important to think about how to use that technology then for good. Now, data is basically the basis for all of this. Yeah, without data, there is no AI. Yeah, if you think about sort of the triangle, at the basis of everything is AI, is data. In the middle tier, they have AI, and they get insights. But without data, AI means nothing. However, the problem is, when you think about data for good, is that data often is a privileged asset. Yeah? And I know that the investors here on stage were making a case that you can build a good business if you don't hand your data over to anybody else. Well, I like to believe that we have bigger fish to fry in this world. There are bigger problems to solve. And as such, having data as a privileged asset is great for a company, is not great for society. And so let me give you an example again from Southeast Asia. This is Manila. And it turns out that 80% of the Philippines is not mapped. There is no map of their roads. There is no map of buildings that are more secure than others. And you have to remember, the Philippines is smack in the middle of Typhoon Alley. They have earthquakes, they have volcano eruptions. Natural disasters happen there all the time. So why isn't this whole country mapped? Because it's not commercially interesting. None of the commercial maps actually go out into the remote areas in the Philippines to map them. There are no maps. And so what we've seen is that the OpenStreetMap Foundation, together with the humanitarian OpenStreetMap group, actually with volunteers on the ground, is mapping out all the different areas of the Philippines that do not appear on a map now. And what is the most important thing is that they then on the map indicate this is a concrete building. If there is an earthquake, this is probably where people need to go to. The Red Cross in the Philippines love these people. Why? Because now suddenly, if there is a disaster, they know how to get there. They know how to reach people with help. And I think that's crucial to make sure that if we want to solve some of the world's hardest problems, we need to make sure that data is not just there for the privileged few. So really, we need to make sure that we can democratize access to data if we want to make sure that we solve the biggest problems in this world. Now, let me say this one more time. You think, if I talk about for good, that these are companies that are NGOs, or that are companies not interested in making money. But it turns out, and it's something that I've learned a long time ago with working with startups in India, that you can actually have a really good business and do good at the same time. We saw that with Hara. Yeah? These farmers, they get an identity and are able to get loans much cheaper than they could do before, don't have to pay for this. It is the banks, it's the government organizations that want access to their data and insight in their data that is actually paying the company for access. And so you can really build a good, sustainable company over time, yeah? But you do to be able to actually do good at the same time. Now, I talked about this before. You need the data, AI is the tooling, and it's insight. Now, where does all of this happen, why these things actually all have come to life around data, is that in the past, we already knew what kind of questions we wanted to ask, and based on the questions you wanted to ask, you collected the data, put it in a relational database, all structured. But when cloud came to life, and you could now store enormous amount of data at very little cost, suddenly everybody started to keep all their data around. There was no structure in the data. There was no predefined query that would run over that data. But still, we had to work really hard then to make sense of this data that you had collected over time. Because maybe there is a pot of gold in there that you look for. And machine learning is this tool to make sense of unstructured data. I always like to say that, this unstructured data is a bit like a haystack. And there's a needle in that haystack that you need to find. So what's the right tool to find a needle in a haystack? A magnet. Machine learning is this magnet. AI is the magnet to make sense and to find this pot of gold or this needle that is in your haystack. Now, one of the organizations that have impressed me most lately is actually an American organization. They're called FORN. FORN tackles one of the hardest problems we have in this world, to create tools to stay ahead of child sex trafficking and actually the sharing of sort of sexual imagery of children. It's a really big problem in this world. Many of these children have been trafficked. Nobody knows where they have gone. We do have imagery of those children, though, of their faces. And so Thorn has developed this system that can automatically process sort of these imageries of these children that have been missing and then compare them against the 10,000 new advertisements each day in the US for escorts. They have, by now, I believe, at least, I think something like 2,000 children have been recovered already out of the hands of these traffickers by sort of the efforts that Foreign is building. And it's not just that. 18,000, the number that I missed, well over 6,000 children. This is increasingly important work. All of this is, by the way, done using AI vision tools. Why do you want the AI vision tools? Because you really can't scale this to the level of scale that is required to find these children in the world. They built a tool called Saver. And so for anyone that is actually allowing your customers to store data on your network, let's say your social media network or collaborative environment, and you want to avoid that this child sexual abuse material ends up on your servers, they have created a massive database of hashes of well-known material, and you can actually really make sure that none of that material ends up on your servers by pushing these images that are being downloaded onto your environment through the Saver system that they've built. One of the most important parts of that, and you'll talk to any social network where people actually have to investigate both imagery and video and is there anything else going on? There's enormous mental anguish if you have to actually look at these images yourself. So anything you can do to actually automate this process in finding this material is crucial. They've identified well over 1 million files and have them be removed and find the original owners of those files and have them prosecuted by the police. Now, to be able to do this, one of the other systems that they are building, for example, is grooming patterns of children, actually follow a particular pattern, and be able to actually push both messaging systems through there. You can early detect patterns of grooming which may result in child trafficking later on. Now, with all of this, I want to emphasize once again, you can only do good AI if you have good data. We really need access to good data to be able to solve some of the world's hardest problems. Now, if you have good data, to be able to make sense of it, you need good AI. And much of the AI that actually works on this data is already available. Don't let yourself get blinded by the whole Gen AI movement, which will have significant impact. But there is already a complete body of work of AI that works really well right now. Also, good work needs good people. And one of the things that I've always been amazed in Southeast Asia is that there is a whole group of entrepreneurs that are willing to forego the idea of becoming a billion-dollar unicorn as long as they can solve really hard problems that are really crucial to their communities and to their society. So with all of that, I want you to walk away with McCarthy's quote. Yeah? As soon as it works, we don't call it AI anymore. With all of that, I hope that you will take this to heart. Yeah? We as technologists have created a lot of technology that actually is not necessarily always used for good. Then it is also up to us to make sure that we start building those tools to help some of the world's hardest problems. And I see many young entrepreneurs here in Malaysia and in the rest of Southeast Asia to really take this to heart, because they really understand these problems and know how technology can help them solve these really big problems in the world. With that, thank you very much.
Thank you very much, Mr. Werner, for sharing with us really insightful use cases on how AI can be used for good.